Hello everyone. Today I'm going to discuss about previous question paper. This is for Triple E and ACE. So let us see the problems in the question paper. Part A consists of total 10 questions. In the 10 questions, we have one problem. Let's see the first problem. A 50 microfarad capacitor is charged to retain 10 millijoules of energy by a constant charging of 1 ampere. Determine the voltage across the capacitor. So this is what we have to find out. So first, write down the given data. Capacitance C value is given, that is 50 microfarads. Micro means 10 to the power of minus 6 farads. And energy retained in the capacitor is given. E is equal to 10 millijoules. 10 into 10 to the power of minus 3 joules. So next, current is 1 ampere, and we have to find out the voltage across the capacitor, V. So we have energy and voltage and capacitance value. So let's take a relation between the energy stored in a capacitor. Energy stored in capacitor E is equal to half CV square. So from this we can write the formula for voltage. V square is equal to 2E by C. Energy value is given 2 into 10 into 10 to the power of minus 3 by capacitance value 50 microfarads. So 50 into 10 to the power of minus 6. So by calculating, we will get V square is equal to 400 volts. So from this, V is equal to under root 400, that is equal to 20 volts. So this is the voltage across the capacitor. So in part E, the theory problematic questions are over. Next, coming to part B. Let's see the first question. So in part B, 11th question, 1A. Find the equivalent resistance between A and B terminals for the circuit given. So I will draw the circuit here. Thirty volts, 70, 175 ohms, 35 ohms, 12.5 ohms. So these are the terminals A and B. So you have to find out the resistance between A and B terminals. Between A and B terminals means from the opposite side of the terminals, you have to reduce the network. See, if you look at 70 ohm and 30 ohm, those two are in parallel. 70 ohm parallel with 30 ohms. Parallel combination equivalent resistance means 70 into 30 by 70 plus 30. It is 210 by 100. So get cancelled, then equivalent resistance is 21 ohm. So the combination of these two, first I'm rejecting these two resistors. These two are in parallel. So you can replace those two with a single resistor, that is 21 ohm. Redraw the circuit again. So in place of 70 and 30, I will connect 21 ohm. This is 175, this is 35, and this is 12.5. So now to reduce the network, so in this 175 and 35, these are not in parallel. See, parallel means the two resistors, one end of the two resistors must be connected. The first terminals of the two resistors must be connected, and the second terminals of the two resistors also must be connected. Here 175 and 35, these two are connected at one end, but other ends are connected to different points. So 175 is not either in parallel or either in series. Next, this 21 also. These are not either in parallel nor either in series. So these are in the form of delta connected network. So before going to that, you can see this here. Across 35 ohm, there is no resistor connected, but there is a wire across this. That indicates that you can neglect this. That whenever there is a wire across a resistor, this branch, whatever the resistor consists of, that branch we can call it as a redundant branch. That means you can neglect or you can remove that resistor. If you have a short circuit across any resistor, then this resistor branch is called redundant branch. Then you can neglect the resistor. So here 35 ohm is a redundant branch. So you can neglect and redraw the circuit. This is 12.5. So 35 ohm, I'm removing it. So only I'm drawing 175. And one more resistor, it is 21. This one end of 174 is this, and one end of 21 ohm is directly connected to this 175, and other ends of 175 and 21 are also connected. That means these two, 175 and 121, are in parallel. So you can reduce the parallel combination 175 or else you can see this 12.5, 175 and 21 all together are in parallel. So not only this 175 and 21, 12.5, 175 ohm and 21 ohm, all the three are in parallel. So reduce the network by finding the parallel combination. 1 by RAB is equal to 1 by, if two resistors are in parallel, you can use the formula R1 R2 by R1 plus R2. Here three resistors are in parallel. So for parallel combination, equivalent resistance 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by RAB is equal to 1 by 5 by 175 plus 1 by 21. By taking LCM and by simplifying this, you will get RAB value 7.53. So this is the equivalent resistance between A and B terminals. So this problem is very easy, but you should not go in a wrong way. Here 35 ohms, if you don't put it as a redundant branch, then it will become complicated one. So check it. There is a short circuit across this. That means there is a wire connected across 35 ohm. So then this branch is a redundant branch. You can remove that 35 ohm. So 11th question. A bit is over. 11th question. 1B. So this 1B question. Again, a circuit is given. You have to find out the current through 5 ohm resistor using Thevenin's theorem. So we draw the circuit. 9 volts, 3, 6 ohm, and this is 5. So the problem is you have to find out the current passing through 5 ohm using Thevenin's theorem. Listen carefully for finding the current passing through a resistor using Thevenin's theorem. So first of all, what Thevenin's theorem is saying, you can replace any given network with the Thevenin's equivalent network. What is the equivalent network? Thevenin's equivalent circuit is, it consists of R Thevenin, VOC, that means open circuit voltage, and the series combination of these two are connected across a load resistor RL. Now the current passing through this RL is the load current IL is equal to, you can find out using the formula VOC by R Thevenin plus RL. So you can replace the given network with this Thevenin's equivalent network. Then you can find out the current passing through the resistor using this formula. But to replace this given network with the equivalent circuit, you need to know about open circuit voltage and RThevenin. And what about RL? In which resistor you are going to find out the current, that resistor will be your load resistor. So in the above problem, what is given, you have to find out the current passing through 5 ohm resistor. So therefore, load resistor RL is equal to 5 ohm. So you have to replace the given network with the equivalent circuit. Then you have to find out the current passing through load resistor. So that is what the Thevenin's theorem. So to find out the equivalent circuit elements, RL is over. Next, you need to find out VOC. So to find VOC, what is the procedure? So to find VOC means, but where you have to find this voltage. VOC is nothing but open circuit voltage. So where I have to find out this open circuit voltage and how to find it. So open circuit voltage means where you remove, to find out this VOC, first you have to remove the load resistor from the circuit. Load resistor means in which you are finding the current, that is the load resistor. So first remove that load resistor and redraw the circuit. This is 9 volt, 3 ohm, and this is 6 ohm. So there is a 2 ohm resistor is there here. So between A, I'm marking these terminals as A and B. Between A and B, I have a resistor that is 5 ohm. That is a load resistor. So I removed that load resistor and I had redraw the circuit. Now we are finding open circuit voltage. Where you open the circuit, between those two terminals, you have to find out the voltage. See, this is the open path. Like this is the open path. That means there will not be any current flowing in the open circuit. If there is no current flowing in a resistor, then you can neglect that resistor and redraw the circuit. Plus, minus. If there is no current flowing through the resistor, you can neglect that resistor. Just remove that also. Now this will become A and this will become B. And you have to find out voltage across this A and B terminals. That voltage is called open circuit voltage VOC. These terminals are directly across the 6 ohm and 6 ohm. Okay. Then this is a simple series network. You can find out the voltage across the 6 ohm, right? The voltage across 6 ohm is nothing but current passing through that 6 ohm into resistor value I into 6. But we don't know the current value also. V is equal to I into R formula. Resistance value is 6, and if you know the current value, then you will get the voltage across 6 ohm. That will be your open circuit voltage. But we don't know about current. So for that, what I am doing, I am finding the current value. I is equal to V by R equivalent. Here V means total voltage in the circuit. What is the total voltage? 9 volts by R equivalent. These two, 3 ohm and 6 ohm, only two resistors are there in the circuit and those two are connected in series. So series equivalent resistance, you have to add 3 plus 6. So 9 by 9, you will get 1 ampere. So the current passing in the circuit is 1 ampere. Now we can find out the voltage across 6 ohm. That is 1 into 6. It is 6 volts. So this is the open circuit voltage. Now next, so we got the value of VOC in the Thevenin's equivalent circuit. Next, what is the value we require? R Thevenin, Thevenin's equivalent resistance. So to find out that, what we have to do? So we are finding to find R Thevenin. So to find out R Thevenin value, first you have to replace voltage source with short circuit. If any voltage sources are there in the circuit, replace those voltage sources with short circuit. And if any current sources are there, replace those sources with open circuit. Then you have to find out the equivalent resistance between the load terminals. In the previous case, what is the network we have? This network. So the same network you have to take. But you have to replace in place of voltage source with short circuit. 3 ohm. And while finding the Thevenin's equivalent resistance, you have to consider all the resistors. You should not neglect any resistor. Why? Because we are finding the equivalent resistance, not a voltage or current. So that's why I'm including 2 ohm also. But load resistor is not required here. But once you remove the load resistor, throughout the problem, no need to connect the load resistor. So in the equivalent circuit only, you have to connect again the load resistor. So between A and B, there will be a load resistor, right? So between A and B terminals, you have to find out the Thevenin's equivalent resistance, R Thevenin, or you can call it as RAB. So if you look into this terminals, current will pass like this and current will divide like this. So 3 ohm and 6 ohm, those two are in parallel. So 3 parallel with 6, because the current is dividing between 3 ohm and 6 ohm. So and the parallel combination of this will be in series with the 2 ohm. So we'll get 4 ohm equivalent resistance. So now connect the Thevenin's equivalent circuit. Make the to find out node current to find IL. So to find IL, what I am doing, I am connecting the equivalent circuit. Equivalent circuit means VOC, R Thevenin, and RL. So then current passing through it is IL is equal to VOC by R Thevenin plus RL. So now we have all the values. VOC value, how much we got? 6 volts. IL is equal to 6 by R Thevenin value we got, it is 4 ohm. 4 plus the load resistor value 5. So 6 by 9, it will become 2 by 3 is equal to 0.66 amperes.
What's dissonance after?
So this is the current passing through load resistor. The problem is over Thevenin's problem. So what we are doing with the Thevenin's problem, to find out the current passing through a resistor, you have to replace the given network with the Thevenin's equivalent network. In the Thevenin's equivalent network, the elements are VOC, R Thevenin, and RL. So you have to find out VOC and R Thevenin. Then you will get the current passing through the load resistor using this formula. So to find out VOC, what you have to do, you have to remove the load resistor. So in this problem, by removing load resistor, there is no current passing through this 2 ohm resistor. So if there is no current passing through a resistor, then you can neglect that resistor. So this will be the remaining network. Now the voltage across A and B terminals is nothing but voltage across 6 ohm. Why? Because there is no other element between these two. So directly the voltage across A and B is equal to voltage across 6 ohm. So that's why I found voltage across 6 ohm resistor. So that is nothing but the open circuit voltage. Next, to find out RThevenin, you have to replace the sources with the voltage sources with short circuit and current sources with open circuit. Coming to the next problem. 11th question 2B. 11th one 2B. So the question given was, find the current flowing through 20 ohm resistor using superposition theorem. So circuit given, I'm drawing here. This is 9 volts battery. Sorry. only 9 volts రాస్తున్నాను. So this is 20 volts, value given as 20 volts, and this one is 5, 10, and this is 20, and again this is 10 volt, and this is current source. A circle consisting of an arrow mark is nothing but a current source. A circle consisting of plus and minus is a voltage source. So find the current flowing through 20 ohm resistor using superposition theorem. So to do this problem using superposition theorem means you have to consider the sources individually. That means we have two sources here. Let us assume V1 is 20 and I1 is 4 amperes. So consider V1 20 volts only first and make this current source 0. How can you make current source 0? By making open circuit. So using this V1 20 volts, find out the current passing through 20. Next case, make V1 is equal to 0 and use this I1 4 ampere. How can you make voltage 0? By making short circuit. So by using 4 ampere source, find out the current passing through 20. So after that, add the two currents. In the first case, you got a current passing through 20, and in the second case also, you are finding the current passing through 20 ohm. So add those two. That will be the current passing through 20 ohm resistor when all the sources are there in the circuit. This is what superposition theorem is. So first, I'm considering 20 volt source. So considering 20 volts means I'm making 4 ampere source is 0. How can you make 0? Redraw the circuit. This is 20. This is 5. This is 10. 10 ohm. And this is 20 ohm. And there is no current source here. I'm not drawing. It is open circuited. And what is our aim? We are finding the current passing through this 20 ohm source. Right? So mark the terminals across this resistor A and B. We are finding current passing through this 20 ohm. So let's see how to find out the current. So you can use any network reduction method to find out the current passing through 20 ohm resistor. You can use either mesh analysis or recording. You have two loops. You can use mesh analysis by writing mesh equations. You will get the currents. Then you can find out the current passing through 20. Or else you can use a current division tool. Whichever method is easy for you, you can go for it. So I will go with mesh analysis. So I'm taking the current directions. This is I1 and this is I2. Okay. So based on the current direction, if current is flowing like this, you can mark the polarity plus minus. Why? Because current always flows from higher potential to lower potential. So this is plus and this is minus. So once you assume the loop current, then you have to mark the polarities. So in this loop, these are the current directions. Then for I2 current, I2 is flowing upward. So here it is plus, minus, and in this branch the current is flowing like this. So it is plus and it is minus. Here current is going upward and here current is going from left to right. So how I'm taking this loop current direction, in any way you can take the direction. So here this is the higher potential. The current will starts here, and at this point the current will divide, right? So based on that, I had assuming the direction. I'm assuming the direction. So now once you mark the polarities, now you can apply the mesh analysis. That means KVL. So apply KVL to the loop. So I'm starting at this point. I will trace the path of the first loop and I will end at the same point. So apply KVL to loop 1. See, in this also you can take two methods. So first thing, when I'm tracing my path, first sign whatever I am seeing, I will take that sign, or else the leaving sign also you can take. See here, the current is entering positive potential, right? Or the current is leaving at minus potential. So you can either take positive or negative. But whatever you are taking throughout the path, you have to maintain the same thing. Suppose if you are taking current entering sign, so for the entire loop equation, you have to take the entering signs only. Suppose if you are taking leaving sign, that entire loop you have to take the leaving sign. So I'm taking the first sign, whatever I'm saying, I'm taking that. So KVL means voltage law, the algebraic sum of voltages. So you have to write the voltage equations. So first sign minus, so minus. What is the voltage here? Directly you can write 20. Next I'm entering what? Plus. So plus sign. So I'm taking plus voltage. V is equal to I into R. Current is I1 and resistance value is 5. So 5 into I1. Next we are entering plus. So plus. What is the resistance value? 10. And current passing is two currents are flowing in this, I1 current and I2 current. I1 is coming downward and I2 is going upward. Two currents are in opposite direction, I1 downward and I2 upward. So then the difference of the two currents will flow in this 10 ohm resistor. And I'm writing for loop 1 equation, so I'm taking I1 minus I2. Difference means either you can write I1 minus I2 or I2 minus I1. But why I'm writing I1 minus I2? For loop 1 I'm writing the equation, so I'm taking I1 minus I2. So after this there is no other element in this loop, so I amended equal to 0. So 15 I1 minus 10 I2 is equal to 20. This is one equation. And if you apply KVL to loop 2, so I'm starting at this point for applying KVL to loop 2. First one I'm saying plus. So plus 10. Current passing is I2. Next, again we're entering positive. So plus 20 I2. Next, I'm entering positive. So plus 10. And again here also difference. But we are writing for loop 2. So take it as I2 minus I1 is equal to 0. Now this is minus 10 I1 plus 40 I2 is equal to 0. By solving 1 and 2 equations, you will get I1 and I2 values. You can do it this directly in the calci. And what is the current flowing in 20 ohm resistor? Only I2 current is flowing in 20. So whatever the I2 value you got here, that will be the answer. Right? The current passing through 20 ohm is nothing but I2. So I2 is equal to, so it will be 0.4 ampere. So this is the current passing through 20 ohm resistor due to only 20 volts source. The current passing through 20 ohm due to 20 volts source is equal to 0.4 ampere. Next, what is another source? We have 4 ampere source. Now consider that 4 ampere source. Due to that 4 ampere source, what is the current flowing in 20 ohm? Now consider 4 ampere source. And redraw the circuit. Only considering 4 ampere means you have to make voltage source 0. How can you make it 0? By making short circuit. So make it short circuit voltage source. In place of voltage source, draw the a line, solid line. That will be the short circuit. This is 5 and this is 10. This is also 10. This is 20 ohm. This is 10 ampere source. So 4 ampere source. So you are finding current passing through this 20 ohm. So for this also you can use the mesh analysis. and I'm going to show you current division method for this. So now I'm reducing the circuit. 5 ohm and 10 ohm, these two are parallel, right? 5 parallel with 10, and that parallel combination will be in series with 10 ohm. So then total resistance is 13.33. So that 13.33 and remaining resistance 20. This is 13.33. So it is connected across. So this is the current. So at this junction point is it where three elements are meeting at a point, that is junction point. So at this junction point, the currents are dividing. The current is dividing. That point is called junction point. So this is the total current for this circuit, and this is current. Let it be I1, and this is I2. I1 is current passing through 20. So what current division formula is? So to find out the current passing through 20 ohm, using current division formula, that means total current into opposite resistance by sum of the resistances. What is the total current for these two parallel branches? 4 ampere is the total current. So 4 into, you are finding current in 20. So for this opposite resistance is 13.33. 13.33 by sum of the resistance. Sum means not the equivalent. Just add the two resistors, 20 plus 13.33. So we'll get the current passing through 20 ohm is 1.59 ampere. And in this also the current is flowing from A to B. So now the current passing through 20 ohm due to 4 ampere source is equal to 1.59. So in this the current direction is A to B, and in the above case also 0.4 amperes. In this case also the current direction is A to B. The current direction is important while adding. So now according to superposition theorem, the current in 20 ohm due to two sources, due to uh, 20 volts and 4 ampere source, is equal to current in 20 ohm due to 20 volts plus current in 20 ohm due to 4 ampere. So it is equal to 0.4 plus 1.59. See, in the two cases, the current direction is A to B only. So that way you can directly add. Suppose if 1.59 ampere, this current is flowing from B to A, then you have to change it to A to B by changing the sign. If it is plus, change it to minus. This two must be in the same direction, then only you can add. So then it is 1.99 ampere. So this is the final answer, the current passing through 20 ohm.